So this is kind of a new project for me. I've built a lot of robotics in the past, always just for fun. I'm a software engineer by trade, so like this stuff has never been a job. I've built 3D printers, bunches of them actually, CNC machines and laser cutters, and it's basically if it runs on Marlin and uses stepper motors, then I know how to do it. I wanted to explore further out of my comfort range and learn how to do robotics that are servo driven. Like usually whenever I'm building a CNC machine or something, it's for a purpose. This time I want to build something that's just a toy, like a really complicated toy, one that I would have wanted whenever I was a kid. So I'm building a SMARS Quadbot. At least that's what it's starting off as. I'm planning on redesigning a lot of the parts, and I'm not using any other software or anything other people have worked on. I'm completely doing it myself. I started off software-wise with Arduino to just kind of learn how servos work and like how to drive them. I've never had to drive servo motors using like a PWM signal or anything like that. I've done a little bit of RC stuff, but it's always been PWM signal goes into this control thing, then the Quadbot is a work. It's kind of a different experience than driving servos, because that's kind of like what it was originally designed for. Like RC receiver plugs into servos, and they're just directly driven by it. So using an Arduino and decoding all of that and recoding it and like figuring out how that works, that was a lot of learning experience there. And it's fast. Something that I learned very quickly was servos always move at their maximum speed whenever you give them a PWM signal. You need to slow that signal down at a rate that makes sense for what you're trying to accomplish. A lot of people who do hobby robotics use a library called ramps in Arduino to do this. So I started experimenting with that, and I got the robot walking around, and it was a good learning experience. But I don't want to use Arduino because it's very limited. I'll be a lot slower at writing code for that. My plan was to shift to using a Raspberry Pi Zero, which I have a couple of those laying around that I've just never used for any other project. There are even some libraries that use the driver board that I'm using for the servos already set up and ready to go, and it works, but it's that ramps problem. Like, you have to be able to produce a signal that slowly eases the position of the servo, because otherwise it just instantly tries to snap to that position. And because I'm using nodejs, because that's the easiest for me to write with, there's no way to perfectly process a smoothing step from one position to the next. I got pretty close. Like, something will ham up inside of the zero, and suddenly the leg will pop its position really hard. And it's very jarring, and obviously it's not going to work for something final. I also tried using a worker thread in Node.js to call this, but it takes too long to marshal that memory around. So I explored how that library actually worked, and I started digging through, and I see that it's communicating using this I2C bus library that's a node-addon-api. After poking around at other APIs and things like that, I found a Raspberry Pi native library that did the same thing. So I started exploring down that route. What I'm going to try and do is write something that's a little bit more direct. I'm going to write a node add-on that directly handles both the setting of the desired degrees, like the rotation of the servo, and handles the ramping in C++ as a node-addon API. And it can just, because the updates coming from the Node.js they're not that fast. They're 250 milliseconds at the fastest. That's like the actual propagation of the animation, like how quickly I tell it leg go here. Like, if I can handle that in C++ using just an add-on, then, well, first I have to learn how to write node add-on APIs, which I've never written before, which are pretty cool because you can just literally write C++ code and connect it to Node.js, and it handles all the compiling and everything by itself. It's like magic. Once I have that working, and once I can set a servo's rotation and loop over time, to ramp it into that position like how the Arduino does, then I can figure out what I'm going to do exactly. Like if that's fast enough, then cool, we're done. If it's not, then we might have to figure out how to like send a couple of frames of animation at a time. So like if the animation is 4 frames and we send 2 frames at a time from nodejs to the add-on, then that doubles the amount of time that we have to process the next one. This also goes into a lot of other stuff that I want to do. I have a camera on it, obviously, and then eventually the goal is to build a kind of VR environment in Unreal that you connect to over Wi-Fi to start with. Has the camera, there that you see, and all of the controls are built into this like 3D experience. There'll be some inverse kinematics built into the Raspberry Pi. And hopefully I can write all of that on the Node.js level and just handle it through the add-on, like I said. So it's kind of these layers. There's the super low level, like almost on the metal C++ add-on stuff that Node.js has. Then the actual Node.js layer that handles like animations and inverse kinematics and things like that. And then above all of that is this Unreal front end that connects to that and lets you control the robot through those things. So this is a pretty big project, and so far I've probably already spent like 100 hours on it, just learning things, and it's walking around. So I mean, I've made progress, and it's been a fun experience. So I'm going to continue to work on this and make little update videos and try and keep myself motivated on it. All right, let's get back to work.